Good morning. Today we are going to discuss about module earth materials, that is module 4. So we are going to study about minerals and rocks in this particular module. Mineral is actually a naturally occurring inorganic solid. It has a definite chemical composition and a definite well arranged atomic structure. And these minerals, they are the building units of rocks. The minerals generally occur in the form of natural aggregates, and aggregates of minerals we call as the rock, and the earth crust is made of rocks. And we civil engineers, we deal with soil and rocks. The major load carried by the building is finally transferred to the hard rock strata which is available at far depth, and it is depending on the strength of the rock. We have to accordingly we design the foundation, we do a lot of soil stabilization works, etc. So ultimately it is the strength of the rock which is of great importance for the civil engineering structures, for the safety and stability of civil engineering structures. So since these rocks are made of minerals, we are going to study in detail about minerals. The study of minerals, that branch of geology which deals with various aspects related to minerals, their individual properties, how these minerals are formed, and where they occur, all these, this particular branch which studies about all these things we call as mineralogy. Now, the physical properties of minerals. So we have about 3000 minerals, and or more than 3000 minerals. So some examples of these mineral groups are quartz, orthoclase, plagioclase. Then we have biotite, muscovite, and we also have hornblende, augite, then hypostene, feldspar, calcite, etc. So these, it is possible to give different names to different minerals and also group them, classify them. All this is possible because each mineral is characterized with a set of properties. So some of which are always distinctive. For a particular group, it will show a particular specific characteristics. So this is always distinctive related to the body of a mineral. For example, its color, shine, shape, hardness, etc. So all these we call as the physical properties. Then we have optical properties. So optical properties means properties like behavior towards light. So we have to take thin sections of minerals and we have to place it under a microscope, and when light is passed through it, how this particular mineral behaves, so in response to light. So that property we call as optical property. And chemical properties, we have to do chemical analysis of the minerals to know the constituents qualitatively and quantitatively. And also we have magnetic properties, electric properties, X-ray, and also how the mineral behaves according when X-rays and other radiations are passed through it. So all these, so depending on all these properties, we classify minerals and we collect information regarding new minerals. Then the major physical properties are color, luster, streak, hardness, cleavage, fracture, tenacity, structure or form, and specific gravity. So first one we will deal with color. So color of any object is actually a light dependent property. It is the appearance of a particular object in light. A particular color is produced by the reflection of some components of white light. So when white light falls on a mineral, some part of the white light will be, some components will be reflected. So a mineral shows the color of that wavelength of white light which is not absorbed by it by virtue of its composition and atomic structure. So we have already discussed a particular mineral will be having a specific or a distinct chemical, a well-defined or definite atomic structure, and there will be definite chemical composition. So by virtue of this particular its own composition and atomic structure, it will not absorb certain fraction or certain component of the white light. So that wavelength of the white light which is not absorbed by it will be the color of the mineral. And on the basis of color, we can classify a mineral into three types. First one is idiochromatic, second one is allochromatic, and third one is pseudochromatic. So let's see what these terms are. Idiochromatic means it is having a characteristics that is fairly constant color. So idiochromatic is constant color. For example, metallic minerals like which belong to copper group. So all these have a constant color. So that is an example of idiochromatic. And allochromatic means it is having variable color. So one idiochromatic is constant, allochromatic variable color. So this variety in color is due to minute quantities of coloring impurities which are thoroughly dispersed in the mineral composition. And many of the non-metallic minerals like quartz, calcite, fluorite and tourmaline etc. may occur in more than two colors depending on the nature of the impurities. Now we have discussed about idiochromatic and allochromatic. Idiochromatic is constant color and allochromatic is variable color. Whereas the third one is pseudochromatic, that is it shows a false color. Such an effect generally happens when a mineral is rotated in hand. Okay. So if you take a particular mineral in your hand and if you rotate it, it is seen to show a set of colors in succession. So first you will see one color, again when you rotate it will show another color. Okay. So this change or play of colors is attributed to simultaneous reflection and refraction from the mineral surface due to minute inclusions of impurities in the mineral at different locations. So there may be impurities in the mineral at different locations. Okay. So when you rotate it, there can be simultaneous reflection and a refraction occurring. Okay. So this play of colors, for example, when you take a diamond, okay, you can see there is a development of series of prismatic colors are shown by minerals when it is turned in light. So these colors they change in rapid succession on rotation and its effect is very brilliant and appealing to the eye. So this play of colors, this peculiar phenomena can be observed in the case of diamond. Whereas in certain minerals like labradorite, okay, the change of colors is similar to play of colors, but the rate of change of colors on rotation and their intensity is rather low. So for diamond, if you rotate, you can see that the change of colors happens at a faster rate, or it occurs rapidly, the rapid rate. Whereas in metals like in minerals like labradorite and all, this play of colors is occurring at a very slow rate. Okay, so that we use the term change of colors. Whereas iridescence, that is some minerals they show rainbow colors either in their interior or on the exterior of their surface. So examples are limonite and hematite. So limonite and hematite, they are minerals which show iridescence, that is another peculiar phenomenon. Similarly, we have another term, that is tarnish. So tarnish means it is described as a phenomenon of change of original colors of a mineral to some secondary colors at its surface due to oxidation at the surface. So here the important words are oxidation. So the mineral surface undergoes oxidation. You know, we have studied about oxidation in physical weathering, in chemical weathering. So we have discussed in detail. So just you have to recall that. Some minerals they tarnish very quickly so that their exterior color is quite different from the interior color. For example, borite and chalcopyrite. So all these two are the examples of peculiar phenomenon, that is which exhibits the phenomena called tarnish. So these terms, play of colors, change of colors, iridescence and tarnish, they're just for you to just have an idea. Okay, these are the different types of or phenomena exhibited by different minerals. So if you are asked about the types of color, okay, then you have to write only about idiochromatic, allochromatic and pseudochromatic. Okay. Then coming to luster, that is the second physical property. So it is the shine of a mineral. It is the intensity of a reflection of light from the mineral surface. It mainly depends on the refractive index of the mineral and the absorption of light capacity of the mineral and the nature of reflecting surface. Some mineral may show a very poor luster on a rough surface, and some may give brilliant luster on a cleavage phase. Cleavage phase means where we cut the mineral. Then the different types of luster. So like in color we have learnt about idiochromatic, allochromatic and pseudochromatic. Similarly, the types of luster are metallic, adamantine, vitreous, pearly, silky, resinous, dull or earthy. So these terms you need to by heart. Metallic means it is similar to, the shine will be similar to metal, like for example is galena, and adamantine, that is very brilliant luster exhibited by diamond. Vitreous, like that of glass, ice, etc., and that is exhibited by the mineral quartz. Pearly type, like a pearl, like the shine of a pearl, so that is exhibited by labradorite. And silky, like that of pure silk, that is exhibited by gypsum. And resinous, that is like oil, grease or wax, by nepheline. Dull or earthy shine means what? Like earth, no shine. Shine is absent, it is not shining, and no light is reflected due to highly porous nature of the mineral, like chalk, clay, bauxite, etc. So these are the different types of luster. So basically you may be asked, what is the difference between color and luster? So color means it is the light dependent property, appearance of a particular object in light, and the color of a mineral is the wavelength of color of that wavelength of light which is not absorbed by the mineral due to its particular chemical composition and specific atomic structure. And the different types are idiochromatic, allochromatic and pseudochromatic, whereas luster is actually the shine. It is the intensity of reflection of light from the mineral surface, and the types are metallic, adamantine, vitreous, pearly, silky, resinous, dull or earthy. Now next is the streak. Important diagnostic property of colored minerals. If a mineral is having color other than white, okay, then we need to know about the streak. So it is the color of the finely powdered mineral as obtained by scratching or rubbing the mineral over a rough unglazed porcelain plate. Okay. So we scratch some portion of the mineral and we put it on a plate. Okay, that plate is made of unglazed porcelain. Okay. Porcelain or china dish, you may have used this in your physics lab, chemistry lab, etc., in your school days and all. So similar porcelain plate will be taken, and on that you will be placing a part of the finely powdered mineral. Okay, you just scratch on the surface of the mineral and you will get the powder. So that powder will be placed on the porcelain plate. Okay, so the plate is called a streak plate. So, and if you observe, you will know the streak of the mineral. Now next property is hardness. Again, hardness, it is the resistance which a mineral offers to external deformation action like scratching, abrasion, rubbing or indentation. Okay, so hardness depends on the chemical composition and also atomic structure or atomic constitution. So in this context, we need to know about the Mohs scale of hardness. In 1822, Mohs proposed a relatively broadly quantitative scale of hardness, and the minerals are given hardness value from 1 to 10. All minerals, when pure, they have found to have a fairly constant hardness value, and there are 10 minerals arranged in order of ascending hardness. Softest mineral is given the value 1 and hardest mineral is given the value 10. So, diamond is given 10. and talc, etc. are given low values. So most scale of hardness we have already discussed, so you just have to recall it. Then next is cleavage. So cleavage is actually the tendency of a crystallized mineral to break along certain definite directions, yielding more or less smooth plane surface. So the tendency of the mineral to break along a particular direction, okay, and after breaking it should give a smooth plane surface. So that property we call as cleavage. Cleavage planes means those planes along which the fracture takes place easily, and they are indicative of the directions of least cohesion in the atomic constitution of a mineral. So when you try to break a mineral, okay, using your hand or using a certain tool, the plane along which there is least cohesion between the atoms, so that will be the weak plane, and along that what will happen, it is very easy to break. Okay, so each mineral will have cleavage in one or two direction, and it is actually the degree of ease in splitting along cleavage directions. And even in a same, but in a one particular mineral, if you take, you can see that it is easy to split in one direction, and if in the perpendicular direction if you try, it will be difficult to break. Okay, so cleavage is described both in terms of the number of directions in which it is observed on a mineral, and also in terms of the degree of perfect splitting. So maybe some along 3 directions if it is possible. Okay, so some for particular minerals, in one plane only you can break it. So also in a particular mineral, suppose in one direction if you break, you will get perfect splitting, whereas in some other direction, you know, it won't be that perfect. Okay, so the cleavage directions are always parallel to the crystal faces also. So we have cubic cleavage, for example galena and halite. Rhombohedral cleavage is there for calcite, and prismatic cleavage, that is basal cleavage, octahedral cleavage. So these are the different types of cleavage. Then in terms of the perfection, the cleavage is described as eminent, perfect, good, distinct and indistinct. Eminent means the mineral can be split very easily yielding extremely smooth surfaces, for example in the case of mica, whereas perfect cleavages are seen in orthoclase and calcite. Then next type is fracture. Next physical property is fracture. The appearance of broken surface of a mineral in a direction other than that of cleavage is generally termed as fracture. In some cases, fracture becomes a characteristic property of a mineral. Like in the beginning we discussed about color and luster. Okay, we may think both are same, but the difference we have discussed. Similarly, the cleavage and fracture, it is the appearance of a broken surface in any direction. So there is a cleavage plane for each of the mineral, one or more cleavage planes, and it is actually these cleavage planes are the planes of easiest fracture we have discussed. Okay, and this cleavage plane indicates the direction of least cohesion. Cohesion means what? The tendency of the atoms to be together or to be in close contact with each other. Okay, so that is absent in this direction. That is why it is easy to break along this direction. Whereas fracture means the appearance of broken surface in a direction other than the cleavage. That is called as fracture. And the common types of fracture are, we have even, uneven fracture is there. Then even means broken surface is smooth and flat. For example, the mineral is chert. Whereas uneven means irregular. There may be ridges and depressions. And example, fluorite. Another type is conchoidal. Conchoidal means the broken surface of mineral shows broadly concentric rings or concavities which may be deep or faint in outline. So the fracture may be, if it is faint, that means very feeble, then it is called as subconchoidal. Example is quartz. Then we have splintery, that is when the mineral breaks with a rough woody fracture resulting in rough projection at the surface. For example, the mineral is kyanite, shows splintery fracture. Then native copper shows Hackley type of fracture, that is the broken surface is highly irregular and there are numerous sharp fine pinching projections. The next property is tenicity. So tenicity is the behavior of a particular mineral towards the forces that tend to break, bend, cut or crush it. So how a particular mineral behaves when we try to break, bend or cut or crush the mineral, that is tenicity. If a particular mineral can be cut with a knife, that we call as sectile. If the slices cut out can be flattened under using a hammer, we call it as malleable. Brittleness means if the mineral change into fine grains of powder when scratched with a knife or when brought under the hammer. So into powder. Okay. Flexible means the mineral can be bent without, that means into thin sheets without breaking. So that is example is chloride. Elastic means the mineral regains their shape when the force applied on them is removed. Mica is example, and plastic, they do not regain their shape when the force applied on them is removed. The next physical property is structure or form. It is the internal atomic arrangement of a mineral which is manifested outwardly by the development of geometrical shapes or crystal characters. The physical makeup of a mineral is expressed by the term structure and is often helpful in identifying a particular mineral. So structure is it's a physical makeup, very helpful in identifying a particular mineral. So the different forms are crystallized. Broadly we can classify into crystallized, crystalline and amorphous. Crystalline means when the mineral occurs in the form of well-defined crystals as represented by the crystal faces and angles, or when it shows perfect cleavage, that is also indicative of the perfect atomic arrangement. So here you can see a photograph. Okay, so here you can see that the crystallized means what? Crystallized means the mineral occurs in well-defined crystals and the crystal faces are all very clear and perfect. Cleavage is also perfect and the atomic arrangement is also perfect. Whereas the second one, crystalline. So crystalline means when well-defined crystals are absent. Okay. Mineral shows a clear tendency towards crystallization as evidenced by development of small grains of which each of which virtually an incipient, it is an incipient crystal, that is proper well-defined crystal faces are not formed. Okay, they are absent, but it is trying to, it is showing a tendency towards crystallization. That is the mineral, it is going to in future, or if the temperature and the pressures, everything is increased, okay, it may get transformed to a crystallized form with perfect cleavage and perfect atomic arrangement. So that is incipient crystal. It is about to form a well-defined face and well-defined cleavage and everything. So that is crystalline, or here you can see polycrystalline. Then the third one is amorphous. Amorphous means neither a crystal face nor a cleavage is seen. So there is no evidence of orderly arrangement of atoms in the amorphous. So basically the form can be of three types: crystallized, crystalline, amorphous. So crystallized means crystallized. So crystallized in it has crystal faces, perfect cleavage, perfect atomic arrangement. Whereas crystalline means what? Crystalline means well-defined crystals are absent, but it shows a tendency towards crystallization. That means it may form these small grains may become perfect crystal faces and perfect cleavage. Whereas amorphous means there is no order of there is no evidence of orderly arrangement of the atoms. Okay, there is no well-defined structure or perfect atomic arrangement. Okay, then next is tabular, elongated. Then we have bladed, lamellar, foliated, fiber, radiating, granular, globular, reniform, mammillary, etc. So these are the other types of form. So we have to study about these different forms also. So this particular figure shows the different forms. So we will explain each one in detail. So first one I am going to discuss is tabular. Tabular means the mineral occurs in the form of a flattened square. Like a square it will occur. So here you can see this yellow colored tabular shaped like a book. You can see it's like a book. Okay, this yellow color like a book, that is tabular. It can be like a square or a rectangular or rhombohedron. Minerals like calcite, orthoclase and barite, they exhibit tabular form. Next is elongated. So elongated, it is in the form of a thin or thick elongated column like crystal. Okay, so here in the figure you can see the bladed or elongated form. Quartz, hornblende, beryl, etc. They show this particular form. Next is bladed. Okay, bladed is also like thin, flat, blade-like overlapping parts. Mineral named kyanite shows the bladed texture. Then lamellar. Lamellar means it. The mineral is made up of relatively thick, flexible, leaf-like sheets. Lamel, like a leaf. Okay. For example, mineral named vermiculite, it shows lamellar form. Okay. So it's like a leaf. So that is lamellar. And foliated. Foliated means the structure is similar to lamellar in broader sense, but the sheets are paper thin. It is very thin like a paper, and it can be easily separated. For example, muscovite or mica, it has this foliated texture. Then we have fibrous. That is when the mineral is composed of fibers. Okay, these are separable. It can be easily separated. So, for example, asbestos. Whereas gypsum, it is difficult to separate, but still the mineral is composed of fibers. So that we call as fibrous. Then next type is radiating or radial. Here in the photo we have blue color lines shown at the bottom right corner. So that is radiating. Example is iron pyrites. Okay, so the like needles originating from a particular point, a common point at the side bottom. So these can be, when these needles are pointed and not radiating, then we call it as acicular. Okay. Then another type is granular. That is mineral occurs in the form of densely packed mass of small grain like crystals. For example, chromite. Then globular texture or botryoidal. Globular or botryoidal. So that also here you can see that green colored photograph shown at near to the center, that is in between tabular and bladed. You can see a green color photo, that is of botryoidal. Here the mineral surface is in the form of rounded bulb like overlapping globules or projection. For example, hematite shows this globular form. Then next is reniform. So in reniform, it is the mineral surface has different bulb like projections that resemble the shape of human kidney. So that is why it is called as reniform. And here also hematite mineral shows this reniform type of form. Then mammillary means similar to globular, but large overlapping round shaped projections are there. So that we call as mammillary. Okay. For example, malachite. So malachite shows mammillary form. Okay. Then in this photograph, you can see some of the pyramidal, dipyramidal. So then a dipyramid, prismatic. So one pyramid, then two pyramids on top and bottom, and then there is a central prismatic. Prismatic means it is having same cross section throughout. Okay, and on either ends you have pyramid. So prismatic with two pyramids at either ends. Then rhombohedron, then tabular, twinned shape is there, cubical, okay. Then botryoidal we have already discussed, prismatic is there, then acicular or needle. So we have discussed about acicular also because radial if they are originating from a common point. So needle like but not originating from a common point, that we call as acicular. Okay. So you may be remembering, okay. Just now we have discussed about acicular. We have the example for acicular form is exhibited by iron pyrites. Okay. Then there is tetrahedron is there. Then dodecahedron. So we know decahedron means it has 10 sides or 10 faces. Since it is a 3 dimensions, it's 10 faces. So dodeca means it is having 12 faces. Then dendritic. Dendritic means again dendritic like the leaves, okay, leaves of a tree. Okay. Then we have fibrous, then scalenohedral, etc. So some of these all those terms which we are included in the PPT you need to learn, and also you need to draw, or you have to illustrate this. Small sketches of these you have to draw because that will be helpful for getting more marks. Then next type of physical property is specific gravity. In mineralogy, specific gravity we know it is the ratio of density of a mineral to the density of an equal volume of water at 4 degrees Celsius, and it is a ratio of, it's like a ratio, no units are there. Non-metallic minerals have low value of density, and value of specific gravity for so this is this is specific gravity means it will be 2.5 to 4.5 and there will be no unit. A density means it is mass per unit volume, so it is 2.5 to 4.5 gram per centimeter cube, whereas metallic minerals and ores have densities at as high as 20 gram per centimeter cube. Then minerals with atoms having greater atomic radii, they show less density values compared with those made of atoms of smaller atomic radii. Density will also show change when a mineral is subjected to elevated temperature or high pressure. So you need to know the specific gravity of some common minerals. Quartz, the value is 2.65. For fluorite it is 3.18 and hematite is 5.2, galena 7.5 and native gold as 19.3. That is the specific gravity. So with that we come to the end of this. Thank you.